Okay guys, let's discuss the JEE main pattern exercises for the very chapter mathematical reasoning. The first question says that if you consider the two propositions P and Q, P says I take medicine, Q says I can sleep, then the compound statement not P implying not Q means what? So not P will be what? If P is I take medicine, not P is negation of P, I don't take medicine, right? I do not take medicine. That's the negation of P. Q is I can sleep, so negation of Q will be I cannot sleep. And therefore not P implying not Q means if I don't take medicine, then I cannot sleep. That's what is implication, if then statement. If I don't take medicine, I cannot sleep, or then I cannot sleep, and that is what is written in the first statement. If I do not take medicine, then I cannot sleep. So the first is the right answer. Easy enough. Just understand what is the meaning of this. This means if not P, then not Q takes place. If not P, then not Q. If P is this, what is not P? Q is this, what is not Q? Just attach if then and you have your answer. Next says if the inverse of this implication P implies Q, you know it is not P implies not Q, then what is the inverse of the proposition P and not Q implies R? Okay, P and not Q implies R. I won't talk about inverse of this. If inverse of P implies Q is not P implies not Q, then inverse of this statement will be not of this implies not of R. See, P implies Q, something implies something. The first statement implies second statement, its very inverse is not of first statement implies not of second statement. First statement implies second statement, its inverse will be not of first statement implies not of second statement. What is this? Just open it up. We know the properties. This is not P, or not of not Q implies not R. This is not P or Q because negation of Q is Q itself implies not R. So this is what you have, not P or Q implies not R. Let's see, not P or Q implies not R. That's the correct answer, not P or Q implies not R. That's the inverse of the given very proposition. Then it says the logically equivalent proposition of P if and only if Q is what? Okay, so you know that this double implication is actually the compound statement, or I should say the very compound statement of two statements. Which are they? P implies Q and Q implies P is what is P if and only if Q. When this holds and this holds, I say this holds. Fine. So it is this answer, that is P implies Q and Q implies P is the statement which is logically equivalent to the proposition P if and only if Q. A very direct question, right? Next you have if P implies Q or R is false, then the truth values of P, Q, R are what? Okay. So for this understand that if I have P and Q as two statements, this can be true or false. When this is true, this can be true. When this is true, this can be false. When this is false, this can be true. When this is false, this can be false. I am talking about the truth table. If I talk about P implies Q, when P is true, Q is true, true. When P is true, Q cannot be false. When P is false, Q can be true. When P is false, Q is false, true. You are getting that first statement implies the other statement is false only in one scenario. Otherwise, every time it's true. It's false only in one scenario when P is true, first statement is true and second statement is false. Therefore, if it is given that P implies Q or R is false, this means first statement is true, this second statement is false, because only then can this implication be false. Now, Q or R, okay, so let me say Q, let me say R. This can be true, true, false, false, true, false, true, false. Q or R, you know the truth table? When either this is true or this is true or both are true, then this is true. If even one is false, this is false. Here it is true, one is true, so true, one is true, so true, one is false, so false. It is given that Q or R is false, but Q or R is false only and only when both Q and R are false. So if this is false, that means P is true, this is false, but this can be false only when Q and R both are false. That means if this is false, this is true, and these are false, and therefore, what are the truth values of P, Q, R? P is true, Q is false, R is false, for P implies Q or R to be false. So T, F, F is the answer. Okay, that's how they basically test you on truth table simultaneously. Next question is if P and, so if P and not Q and not P or Q is the statement given, then what is it? Is it a tautology? Is it a contradiction? Is it both or is it none? Let's begin. I have P, Q. So P can take values true. At that time this can be true or this can be false. When this is false, this can be true, or when this is false, this can be false. Not P will be false, false, true, true. Not Q will be true. No, here it will be F because here it is true. So not Q is false, true, false, true. First thing is P and not Q. Okay, so P and not Q. P and not Q. And statement is true only when both the statements are true. Only when both will be true will this be true. So P and not Q. This is true, this is false. This is false. This is true, this is true. This is true. This is false, this is false. This is false. This is false, this is true. Again false. Even if one is false, it's false. For it to be true, both P and not Q should be true, which is only happening once. So this is P and not Q. Then you want not P or Q. So not P or Q. Okay. So not P or Q. Either this is true or this is true, then this is true. This is false, this is false, this is false. True, true. And then you want their conjunction, and. So you want and of these two statements, which is P and not Q and not P or Q. Clear? And is true only when both are true. So this is false, false because both are not true, again both are not true, again both are not true. You can see the very answer is false always, and therefore this given statement is a contradiction. Clear? Not a tautology. For tautology I wanted true everywhere, but here I am getting false everywhere, and therefore this is a contradiction. Moving to the next question, which of the following statements is always true? Which of the following statements is always true? Let's see. P implies Q is logically equivalent to not Q implies not P. You should know that P implies Q is actually logically equivalent to not P or Q. This we've done. P implies Q is logically equivalent to not P or Q. So if I talk about not Q implies not P, this will be logically equivalent to what? Not of the first statement or second statement. Not of the first statement or second statement, that is Q or not P. So this is also logically equivalent to not P or Q. This is also logically equivalent to not P or Q. Therefore, they both are logically equivalent to each other. Talking about the next, not of P or Q. not of P or Q. You know by the rules this is not P and not Q. But here it is not P or not Q. I want and, this is wrong. Not of P implies Q. I just told you what is P implies Q. P implies Q is this. So not of P implies Q is actually not of not P or Q, which is not of not P and not Q. P and not Q, but here you have P or not Q. So again this is wrong. And not of P and Q is not P or not Q. Not P or not Q I wanted, I did not want and, so even this is wrong. Fine. After this, let's see the next question. The contrapositive of the statement that if 2 square is 5, so this is one statement given to you. So this is P. P statement is 2 square equals 5. If P, then I get first class is Q. This is Q. So you have if P, then Q given to you. So P implies Q is given to you. And you are asked what is the contrapositive of this statement. You know that if P then Q is actually represented by P implication Q. What is the contrapositive? Contrapositive of this is given by not Q implies not P. If Q is I get first class, not Q is I don't get first class. Implies not P, P is 2 square equals 5, 2 square is not equal to 5, is not P. This implies this means if I don't get first class, then 2 square is not equal to 5. So what is the contrapositive? That if I don't get first class, then 2 square is not equal to 5. If I do not get a first class, then 2 square is not equal to 5. This is the contrapositive of the statement. If 2 square equals 5, then I get a first class. Interpreted as P implies Q, and therefore its contrapositive is not Q implies not P. If you have Q and P already there with you, you can very easily interpret not Q and not P, and then you can get the result of contrapositive statement. Which of the following is wrong? Okay. So this time the drill is I have to tick the wrong one. I don't have to tick the right one. Just now I told you that P implies Q is logically equivalent to not P or Q. If you don't believe me, you can also check this out. This is P, this is Q. True, 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 false, false, true, false, false. P implies Q we just drew as true implies true is true, true implies false is false, false implies true is true, false implies false is true. And then you have not P or Q. What is not P? It will be false, false, true, true. Not P or Q. This is true if either one of them is true. So this is true. Then false, false. Both are false, so false. True, true. So true, one is true, so again true. You can see this is exactly the same. The truth values are exactly the same, and therefore both these are logically equivalent. So first is right, and therefore for me it is wrong. For this question it is wrong. If the truth values of P, Q, R are T, F, T respectively, then the truth value of this is what? Understand carefully. P or Q and Q or R. Let's see. P or Q and Q or R. It is given that P is true, Q is false and R is true. If P is true, Q is false, P or Q will be what? P or Q is true when at least one of them is true. P is true, Q is false, so this is going to be true. If Q is false, R is true, again this is going to be true. And if this is and. If this is true and this is true, this is true. So the truth value is true. This is again the correct statement, and for me it is wrong. Then you have not of this is logically equivalent to this. Now this is very easy. You know by the rule, this is not P and not Q and not R. So this is again the right thing. So for this question it is wrong. The truth value of P and not of P or Q is always true. That means they are trying to say this is a tautology. Is it true or not? Suppose I take P to be true and I take Q to be false. If P is true, Q is false, P or Q will be true, because P or Q is true when at least one of them is true. P is true, Q is false, right? If this is true, okay, so if this is true, not of this will be false, right? Not of this will be false. I have taken P to be true. P and not Q is true only when both of them are true. Here you can see P is true and this other statement is false. So this completely it is going to be false. So it's not the very case that this is a tautology, because when P is going to be true and Q is going to be false, in that case this statement is going to be false, and therefore it cannot always be true. Therefore this is the wrong answer out of all four, and therefore by the question this is the right answer. Clear? Moving on to the next, we have, let S be a non-empty subset of R. Consider the following statement: there is a rational number x in S such that x is positive. That means in this set S, there is one rational number for sure. There is one rational number for sure which is positive. Question is, which out of these is going to be matching to this statement basically? Every rational number x in S. So let me say, if S is a non-empty subset of R, consider the following statement: there is a rational number x in S such that x is positive. If over here I ask you, negation of P is what? What is negation of the statement P? There is a rational number x in S such that x is positive. Every rational number x in S such that x is less than equal to 0. Are you understanding? What I am saying is there is exactly one point in the set S which is positive. Its negation is there is no point like that in S which is positive. That means all points which are in S are actually non-negative. None of them is positive. That means all points in S are this is positive. That means this is less than equal to 0. They are negative, not non-negative, negative. So what I am trying to say is, if the statement is saying that inside the set S there is exactly one point which is positive, its negation is there is no point like that which is positive. That means any point you take in S, it is negative, or I can say every rational number in S is actually negative. So not P or negation of P, where P is there is a rational number x in S such that x is positive, is what? Every rational number x in S is negative. Clear? And the next question we have, consider the following statements: Suman is brilliant, Suman is rich, Suman is honest. The negation of the statement Suman is brilliant and dishonest if and only if Suman is rich can be interpreted as what? Okay, slowly and steadily. Suman is brilliant. Suman is brilliant is P, and Suman is dishonest. Suman is honest is R, so Suman is dishonest will be negation of R. Suman is brilliant and Suman is dishonest, that means P and not R. If and only if, so this is double implication. Suman is rich is Q. Question is, find the negation of this statement. We have interpreted the statement, its negation will be this, which is not of P and not R, if and only if Q. Let's understand once more. Suman is brilliant is statement P and Suman is dishonest is not R statement, because R is Suman is honest. So, not R will be Suman is not honest or dishonest. So, Suman is brilliant is P and Suman is dishonest is not R. So, this is the statement. If and only if Suman is rich, that is Q. Negation of it is negation of this complete statement, and therefore what is given to you is negation of Q implying P and not R. This is the right answer. That's how you basically deal with all the concepts related to mathematical reasoning in questions, and mind it, truth tables are very important, so don't forget to practice them. That's it from my side. Thank you.